All right, so let's get started a little bit. The point of this particular panel is to talk about LabVIEW and other languages, particularly Python, but also there's C#, something like that. And basically trying to figure out what's the best tool for the job and when to use one versus the other, and then also how they can work together. And any tips and tricks for a LabVIEW programmer who maybe finds themselves needing to learn Python or C# or some other language. What are the things to look out for? What are the big differences? So let's go around first and just have all the panelists introduce themselves and tell us a little bit about yourself. Try to keep it kind of brief so we get around through everybody. And just, yeah, Jesper, why don't you go first?
Yep. So I've developed a couple of things in Python. Basically, whenever we need to do something that's already been implemented in Python and is working in that has not been implemented in LabVIEW, I would definitely suggest moving there, unless you really want to build a new library for LabVIEw, or you have to use it on real time, which is the other case where it's actually a problem. But for my own side, I've built a couple of toolkits. One of was actually making sure that you copy all the dependencies for your DI package whenever you need to install all of them, making sure that it has all its dependencies in local. DI packages are only zip files, so they're quite easy to read in Python because you can do it in memory. So that would be one of the projects that I use it for, which is an analysis for DI packages.
All right, Jim, why don't you go next?
Okay, hi, I'm Jim Kring. I've been using Python for about 20 years. And the first project that I was working on Python was actually being interoperable with LabVIEW and controlling LabVIEW applications with Python to use it as a text-based scripting language for Python, which is pretty fun and cool. And then I sort of used it sort of intermittently over those 20 years as it kind of grew in popularity. And then over the past several years, I've been using Python a whole lot for a lot of web stuff. The IPM.io website is implemented in Python. Lots of parts of Dragon are implemented in Python. And I have been also dabbling in other languages like Rust recently. And I think what I'll kind of throw out there is I'd be kind of interested in seeing how we can encourage LabVIEW developers to learn languages other than LabVIEW so that we can kind of broaden our horizons about, you know, how other languages do things and how we can apply that to LabVIEW. And thanks for having me.
Yeah. Ching-Hwa, why don't you go next?
Yeah, sorry, did you mention me? Yeah, so yeah, my name is Ching-Hwa. I'm a senior manager at AMD. So we implement Python for a number of different reasons. I run a bunch of teams, and we use it for both internal as well as external open source things that we do. Yeah, so I've actually moved 100% to Python. And some of you are probably wondering why I'm here. Well, I'm one of those OG LabVIEW developers. I started with LabVIEW 3.1, and I think the last version I touched was probably like 2018. So I have a very different view of when and why you should use Python, if you can kind of get a sense for that. But most definitely, you can do what I would echo what Jim said. If you're going to interact with Python from LabVIEW. There's all sorts of different things you can do inside of Python. It's just simply not possible with LabVIEW. One of those things being like dual inheritance and a lot of different other things that we can certainly get into.
Great, thank you. AJ, why don't you go next?
Hi, Sam. Thanks for the seat. I'm Ajay, or Ajay, people call on their own. And I've been in LabVIEW for quite a long time, and I started using Python a few years back and integrating the Python for some of the projects, the libraries in Python to use in the LabVIEW. And kind of I saw the interest around that in many places, and very recently I started looking at quite a few of my colleagues, used to be colleagues, started migrating from LabVIEW to pure Python, just like Ching-Hwa, who has said now. So that's the main interest to me, to know what's happening around in the places. What power does Python brings in, or what we are missing in LabVIEW? We do have the Python integration tools, and there are some limitations we find. Python being a very moving target, it moves very fast, and chasing it is definitely a hard job. But how people are chasing it, things like that.
All right, Vinod, would you like to go next? We can't hear you. Okay. Yeah, leave and come back if you are having issues. All right. So let's get started with the question. Like, what are the best use cases for using something other than LabVIEW? So, what part of a project, when you get a new project, what in your mind would say, oh, this is a better fit for Python or some other language than LabVIEW, or vice versa? What things say this is a great fit for LabVIEW? I'll see Jesper goes first, and then we'll just kind of people can chime in as they have something to say.
I would say some of the places where Python would shine compared to LabVIEW is looking at, for instance, reading your environment variables on your PC. It's not common usage, at least not to me. Or the projects that I've seen, having something that's local only on the PC, whereas in Python you would have your database access keys or other AWS keys for all your web stuff. Instead of putting it in your code, you would put it in your environment on top of on the PC, and then set it up every time you would need it. So that way you would use that instead of then read it out in the code whenever you needed it. Whereas if you wanted to do that in LabVIEW, you would use some sort of dark magic of going through the registration database, which is the other way of going into getting these informations. Unless there's a toolkit that I've missed somewhere. So I would say that's some of the issues that and as Mike points out in the chat, is text parsing as well. There are many toolkits in Python that you don't have to reinvent in LabVIEW just to make it work, unless you really want to do it on the real-time systems.
Yeah, there's also a couple other comments there. One is AI. So I guess Python has a bunch of built-in AI libraries. Anybody else have any other comments on?
Yeah, I mean, it's just it's not necessarily built into Python, right? There's like a whole entire ecosystem of developers that are developing all these crazy libraries that they do all kinds of insane stuff. You know, especially in the numerical analysis side of things. All right, so you got NumPy, you got Pandas, you have TensorFlow, you have PyTorch, all these libraries that are getting built at insane speeds. That it'll never be able to be recreated in the LabVIEW world.
It's worth mentioning too that a lot of those libraries that you mentioned, the core internals of those are written in C, some of which are written in Rust, and so I think what that points to is historically and probably currently for a while, Python is kind of considered a glue language, and it's useful because it's highly interactive because it has a REPL. I forget what REPL stands for, right? Read, print, whatever. You can basically have a command prompt and you can say X equals 1, return, Y equals 2, return, and then say X plus Y, and it'll output whatever that adds up to.
Read, evaluate, print loop.
Yeah, exactly. And so it's highly interactive. Plus, there's interactive notebooks, which will actually, sort of remember the state of certain parts of your program, and then you can plot, and then it integrates the plot in there. So it's a highly interactive, dynamic language. And so people have really kind of used it for its interactivity, and then also to glue certain things together. For example, provide a nice user experience around some really fast, powerful, low-level tools written in other languages. And so I think, providing at JKI, we provide Python-based APIs to the instrument project control systems that we develop to allow scientists and engineers who, they know Python already. Text editors are free. They can just, move stage in, move stage out, check to see, did it break? They can do that stuff really easily without, having to open up a huge IDE or anything like that.
So Jim, I'm curious, in those situations, do you still have a LabVIEW program that then has a Python interface, or you write everything in Python? Okay.
It's LabVIEW with a Python interface.
Okay. Cool.
Based over TCP, or have you developed other ways into it?
So is that so then my next question then is, how can you use LabVIEW and Python together? And we all know about the Python node, but is TCP the best way to have them running in parallel and talking to each other, or how do you?
Well, I mean, that's a communication message bus, right? And so that's probably a great way to do it. I think a lot of things are moving towards for LabVIEW, that's probably the best way to do it. If languages if you have an application written in like C, C++, you can actually embed the Python interpreter and compile it directly into your application and expose a Python API that way. And a lot of large applications actually do that. And with LabVIEW, I think the future of it is probably going to be to export like a gRPC API to your application. People have talked about ZeroMQ being kind of an easy kind of protocol for transmitting data back and forth. The stuff that we do is just TCP/IP.
But I guess one of the things, at least from my point of view, is the implementation in LabVIEW, which actually the hard part is all the stuff around getting it to work, which is why I did a presentation on last year, was trying to install Python in the right way in a componentized solution that you could install with your LabVIEW installation or runtime installation. So packaging it up without baking it into the application, but installing it around either LabVIEW or TestLab, which seems to be one of the hurdles. But I also think as a community, we need to start to look into another part, which is all the training and information for Python is freely available on the internet.
Yeah,
you can take a paid course, but you could also spend 8 hours on YouTube, and you'll probably get the same information that somebody did a paid course on. We don't have that in LabVIEW. We have paid courses, and there are some really good trainers out there. I don't discredit them, but we don't have free access to all the information.
Yeah, and that's one of the main point I see. Quite few of my colleagues has starting to moving out, specifically the expense incurred for doing anything on LabVIEW. So you want in first place a license for any commercial activity they perform in their day job, and it all comes to the point that making a decision of buying a large amount of license for characterization team or someone like that. And that is one of the key factors in deciding going to open source like Python and availability of all the libraries as well.
So I shared a link related to some questions people were asking. So in terms of distributing Python, one tool that I discovered and I actually started contributing to the project is called Nutka, and it's hard to pronounce and spell. But basically, it's a Python compiler that's written in Python, and it transpiles to C, and then also pulls in all the dependency DLLs. If it can compile in the libraries, it compiles them indirectly. And it can build single file executables or standalone, folders that package in the entire Python interpreter that gets compiled to. And it's very performant. It's free. They have a commercial version with some other bells and whistles like obfuscating your string constants and things like that, function names. And so that's really powerful. Python's actually getting a lot faster too recently. So there's ways to do all this stuff, but it's all like nebulous in this huge worldwide community.
But I guess also if you need to do something multi-threaded, doing it in, well, it's hard to compare the two because we know how to do it in LabVIEW, but compared to setting up a threaded system in Python, either with maybe actors, they do have libraries for this.
So that's true. Yeah.
It's really compared to making two while loops that are running in each of their own threads, or if you need to do it with time loops instead, it's sort of easier.
Yeah, that's we're like right on the edge where Python is being pushed for performance and also kind of multi-threadedness. The work going on in Python right now, they are working to have like one GIL. They call it the global interpreter lock, which kind of prevents more than one thing from happening at a time. And they're going to allow you to have one GIL per interpreter, so you can actually kind of spawn multiple interpreter instances. And then there's a group working on Python no GIL, which basically would completely cut out the GIL. And then there's also some folks working. So there's a library called Numba, which is a JIT compiled Python that basically JIT compiles to LLVM. LLVM is the low-level compiler that LabVIEW uses under the hood. And then there's a group working, I think Intel and some other folks, on open multiprocessing, OMP. And there's a group working in Numba to add extensions so that the JIT compiled Python can actually have certain declarations for parallelism. So you can do like parallel for loops and spin up threads in parallel. So people are working on it, but it's definitely not there yet for prime time.
There is a question in the chat for you, Jim, about Nutka over PyBuilder. I don't know anything about PyBuilder. So.
Yeah, I haven't used PyBuilder, but I looked around at all the different stuff available, and they take different approaches. I think a lot of like PyBuilder, I believe, and some other PyInstaller, they basically create your own installation of Python that is kind of self-contained. Whereas what Nutka is doing is actually transpiling to C and then compiling it. And that's nice because it's much, much faster. Sometimes like, 10 times faster.
But I guess Nutka would suffer from the same problems as PyInstaller would, whereas signing the code is actually a second step that you need to handle. Otherwise, you're
talking about signed executables?
Yeah, exactly. So otherwise, your antivirus will come and snipe your build.
Yeah, that's an issue. It uses you can specify which C compiler you want to use. So you can use MingW or whatever, which is kind of the open source one, or you can use Microsoft Visual C as the compiler. And then there are certain things that they recommend doing to help avoid antivirus. They've got a whole kind of page on tips and tricks to where to submit your stuff.
So there's a question about Python libraries using NI hardware. So I have a question then. If you're using NI hardware, is there any reason to use Python to talk to the hardware? Is it easier to talk to it in LabVIEW, or do you have any opinions about that?
I'd say today it's easier to use it in LabVIEW, but I know that like NI is starting to publish more Python libraries for like, DACMX and other stuff. I actually haven't used that stuff much, but I also know there are some Python Visa libraries that are out there in the world. Ching-Hwa, you probably know more about this than I do.
Yeah, I mean, there's a lot of, you can see the documentation that AJ put up there that talks about the support that NI has provided for Python developers. But yeah, a lot of the stuff had been community driven for some time, and I think NI has kind of been behind the curve in terms of both Linux and Python adoption. So yeah, hopefully they're going to catch up. I mean, they've done a pretty good job on the Linux side of things.
Yeah.
In recent years. I hope they really do more on the Python side.
So they have like on FlexRio, and we're kind of talking about other languages here too. We're working on a project where we're trying on Linux to kind of be interoperable, like with, CUDA for GPUs plus FlexRio for doing the high-speed digitization. And LabVIEW has essentially like a C API for LabVIEW FPGA, and essentially what it does after you build a bit file is it generates all the C files and the header files so that you can talk to your FPGA in C. And I would imagine, one could then call that from Python. Typically, though, I typically think you're not going to see Python used in real high performance applications. I still think, you're going to see, LabVIEW, FPGA, RT, but then things are going to be in, C++, Rust now. A lot of people are adopting.
Maybe just giving a callback to my previous presentation where we had one of the ideas we have in the GID exchange is actually to use VI scripting to create calling nodes for a Python file. So if you specify a set of functions that you expose through a Python file, then you could script your way into having this as VIs that you could drop into a block diagram. But the downside is that trying to scope the project because the Python specification is quite large.
Yeah.
So finding a minimum viable product that actually works for this part is the critical factor here.
Yeah.
Yeah.
One of the more popular some of the more popular projects in Python are based on the Pydantic library. So Pydantic leveraged the new type hinting that came into Python. And what Pydantic did is they defined kind of a way to describe data classes. And with your classes, you can essentially declare the data types, default values, and a bunch of other cool attribute things like validators. Like you can have functions that validate the data when your serialization, deserialization happens. And then a lot of folks have then leveraged that library for things like Fast API, which is like up and coming, the #1 like web interface, web server sort of interface for Python. And essentially what these tools that leverage Pydantic for defining all the data structures, it allows a lot of like real kind of like dynamic code construction that basically it serves as an interface descriptor. And I think that that's what you were getting at, Jesper, is like the idea that you can look at a Python script and then see the functions and the data structures, and then automatically script the LabVIEW side that talks to that.
The downside is that the Pydantic part is sort of the cutting edge, and therefore it's not really implemented in
everything. Yeah.
Yeah, exactly.
Yeah, they're on the cusp of 2.0. And that's the thing too. Python moves really, really fast. You know, like their versions of Python are only supported now officially for like a 3-4 year window.
Exactly.
Yeah, I looked at that project, the project to do the scripting, and the first thing I thought was types would be a problem because, you know, the Python doesn't, if you don't have any type hits, how do you know what type it should be without then having the user specify them all? But, so there were a couple other questions about hardware. I saw your question, Mike, about low-level stuff like I2C and SPI. And is that easier? I assume that's easier to talk to in Python, but is that also easy to talk to in Rust and other languages, or is it mostly, what are you guys' thoughts about that?
So go get a Raspberry Pi Pico and put MicroPython on it and write a little code that talks over I2C SPI, and then, you know, you can also create like a serial port listener on it, and now you've got like a $4 I2C SPI adapter.
Actually, for $5, you can get the Wi-Fi one and then put the MQTT on it, so you could actually talk directly to your LabVIEW application.
Exactly.
Yeah, cool. And then there was a question from Kevin about hardware abstraction layer, and if it would be easier to write a hardware abstraction layer or better to write one in Python or in LabVIEW. And if you had any thoughts about that.
Ching-Hwa, this one's for you.
Yeah, I would say it's easier to do in Python. So to code like the factory pattern is so much easier to do in Python, just because you can do
metaprogramming, right?
Yeah, you can do, you know, so, you know, when you instantiate objects in Python, you don't have to, you can actually, how do you call it, transform the class that you're instantiating.
Yeah, you can code classes at runtime.
Yeah, that's what I'm trying to say.
Yeah.
And then you can do all kinds of things dynamically that you just can't. It's just not possible in LabVIEW.
Jim echoes the others.
So it's the duck typing or that looser typing system that makes it a lot easier in Python?
I wouldn't say it's necessarily the duck typing part of it. It is just that getting access to, everything in Python is an object. So just getting references to objects is so much easier, and then you can just then, pluck them out of thin air and then just use them to however you like.
And so different than duck typing is like the meta programming. So classes are objects, and so you can instantiate a new class at runtime, and then you can add attributes and functions. You can dynamically build up a class that you then create instances from, all at runtime. And so people use this, for example, like the Amazon Web Services API, like Bato 3. Like, I think the whole like set of objects that you kind of interact with all get kind of constructed dynamically based on, an interface specification that's kind of negotiated and probably pulls down the spec as JSON or something, and then it builds up all the objects dynamically. So they don't have to manage a whole code base.
But whether you can do it is one question. The second question is, should you do it? Because sort of the way of creating more complex software because you can is not always the best solution. And I also think one of the Achilles heels of both Python and LabVIEW is that even without a lot of experience, you can actually make something work that somebody who has no idea of what you actually did but seen it work actually will say that's now a product. And then you're stuck with it for a very long time until you can actually refactor something, which brings it to one of the other problems that in having to manage all the software dependencies, all basically the computer science stuff that you actually need to do in order to do good software, applying solid principles, using good software practices. All of this applies to both LabVIEW and Python. That's nothing new, but a lot of people just disregard it because, hey, it works, and then somebody else needs to look into it, and then there's 12 different things, and you have to wear a special hat in order to actually change the code, and then you have to install it in a specific way and delete 5 files in order to get your project running when you share it to somebody else. So that's the downside of these both of these is to have, if you're not really stringent about your development project, this is really something that will hit you down the line. Even if you're running on a Jupyter notebook, because it's easy to do it in that. There is a different set of problems.
Have you guys heard of the term monkey patching? So it's kind of similar like duck typing or kind of dynamic. So in Python, because of the fact that even classes themselves are dynamic, what one approach you can do if you find kind of a bug or a feature that you don't like in a component you're using, you can just instantiate it. And then if a certain method doesn't work, you can just override it dynamically in your scripts. You just say my component dot function name, and now that function's pointing someplace other than the author intended it.
Best use
Not recommended, but sometimes in a pinch, you got to do it.
Yeah, that works really well for testing things sometimes, but outside of testing, that's treading on thin ice, I think.
Just one thing, just for answering Kevin in the chat, for static analysis of Python stuff, there are several tools which are all good, but what the sort of the Python community actually came up with now is to have the black formatter, which actually goes in and it changes your code so that it matches the PIP8 formatting. And then nobody discusses how much the formatting is anymore. Sort of like if everybody set all your VI wires with 8 pixels in between, and everything was aligned in a certain way. If the auto cleanup function in LabVIEW actually worked in a way that would make it look nice, if everybody could just agree that you had to push that and that would give you the same result every time, then that would be the same solution.
And people run pre-commit hooks in the source code repository. So like on GitHub, you can set up a file and then kind of subscribe to, it's not like a paid service, but essentially what'll happen is when you do commits, it'll run the black auto formatting and it'll commit the changes for you, like fix the bent wires, so to speak.
Yeah, so for Visual Studio Code, when you install the Python extension, it also comes with Pylance now. So Pylance is an advanced static code analysis tool that will go in there and do all kinds of things to warn you of things that don't exist, undefined, things that are not linked properly, all those things.
That brings up an interesting point of just curious, what Python IDEs do you guys use? I use PyCharm. Does anybody else use that, or do you guys use something different?
Visual Studio Code.
Yeah, I use the code.
I like PyCharm. However, I find more and more I'm getting pulled into VS Code.
Huh.
Yeah, like some of the features are only available in professional PyCharm. Especially if you want to do like the SSH tunneling into remote debugging. So that those features are only available in professional PyCharm.
Okay. Cool.
If I remember correctly, Visual Studio Code is also shipping with test stand, or at least being suggested as the test stand implementation. So they're promoting some new features on that.
Huh, that's interesting. So let's see. The other thing that somebody had mentioned in the chat is that they had seen that Nathan said something about, I think it was, talking about Python is competing more with teststand rather than LabVIEW. I'm curious to hear you guys' thoughts on that. I have heard of people, like Jim said, writing test systems where then people script it in Python to interact with your test system, as opposed to like doing stuff in teststand. Any thoughts on that? Jesper, raise your hand.
If you're listening to one of the Python podcasts, you'll come across the Python Bytes podcast, where we have Brian Ocken. He works for Rode and Schwartz, and all of his test code for all Rode and Schwartz implementation that goes through his hands is in PyTest. So it's basically set up the entire test system with PyTest.
Interesting.
Yeah, a lot of people. Yeah, I was just going to say a lot of people like to have file-driven tests, right? They don't necessarily like to go through a UI, and configure that way. They just want to do it through files, whether through scripts or through INI files or YAML files or whatever you want to set up your configuration. But you just want to launch it on the command line and have it go.
Yeah, just like that. It's basically competing against test and one of the semiconductor industry, a big semiconductor industry, just have a complete Python test framework built up, and all the engineers can just write up the different small test cases for the characterizations.
Yeah.
And yes, Ching-Hwa said it's only a simple configuration files, and it's in a very fast turnout. They are able to run the test and bring up the test all together.
Okay, I have another question here related to that. Has anybody used the robot framework for Python, which I have seen, but I haven't actually played with? Apparently that is kind of a sequencer type program that seems to compete with teststand.
What's it called?
It's called Robot.
Nope.
Okay.
I've heard of good things about it.
Okay.
I've seen it used. I mean, personally, I prefer just to write everything in PyTest because it's just like writing normal Python code. If you wanted to do a lot of parameterization, it's all available.
I will say for unit testing, I am very much a big fan of PyTest. It's like super easy and simple, and it's like 3 lines of code and you write a test. And so if you're not doing TDD in Python, I highly recommend it because it's super easy. So.
But another thing that we could use for Kjær, maybe Jim, I don't know if it's you or Francois I need to push this to, but one of the things we have in in PyTest is the ability to set a test to fail, and then to sort of expect a fail, and then expect it to when it then suddenly doesn't fail anymore, then you flip the switch, and now it's an expected pass result instead. But that would require you to go change the VI at the moment. You can't, as far as I see it, script it outside, sort of in that way.
I have not discovered that feature yet, but I'm going to have to look at that now.
And where does PyTest store that setting for a test?
I believe it's in the parameterization of the PyTest functions.
Okay.
You can set it up. I'm quite sure, but I will have to look into it.
All right, we have another question, and somebody is the main concern they've got pushback from higher ups about using Python is being able to properly license the product, because if you ship Python code, it's just a text file and people can look at it. I think that probably goes back to what Jim was saying about building executables. That would probably solve that problem.
Yeah, so the Nootka tool, in addition to building kind of standalone executables, it can actually compile the modules themselves into PYD files, which are essentially, binary executable code that's sort of wrapped in a DLL. And I think it is a DLL that just kind of conforms to the Python module kind of interface of what all the inputs and outputs are for it to work. So that's one option.
But isn't that reversible in the disassembly instructions?
I think it probably is.
Yeah, and everything is.
Yeah.
And so, I mean, if you go down a rabbit hole really quickly when you start to talk about
You have to be really secure, don't distribute it. But if it ever leaves you the key and then nobody else can figure it out. Like that.
Yeah, if you want people stealing your code, build web apps and host it.
So one last question, then I want to change direction a little bit. Has anybody tried Python-based actor framework? Something like Robot OS, ROS, Robot Operating System. I don't know if anybody's tried that. Most of my Python scripts have kind of been straight through, and maybe occasionally like a side thread, but I haven't really done a lot of multi-threaded stuff in Python.
No, I've explored it. There are actor frameworks that folks have developed for those languages. I know there's one or two in Rust that are, kind of implemented off the same kind of model as LabVIEW's actor framework. I think one thing we haven't talked about that's worth mentioning is async in Python. And so there's this kind of whole kind of programming paradigm that uses async IO, and one can declare functions as async functions. And then if functions, once they get through their own synchronous work, and they can call asynchronous functions as well, but then they can do an async wait. And that wait, if they call the async wait, it actually then frees up processor cycles for other loops and asynchronous functions that then need processing time. And so I think they call it cooperative multitasking, because all the functions in the program kind of have to kind of agree to use these async waits in order to allow things to kind of start to happen more in parallel to each other.
But I would highly recommend it. They have actually had this part about async all the way back from Python 6 or something like that. The thing was, it was called generators back then, and nobody really understood how they worked.
Yeah.
But now it's moved to being implemented as async, and there are plenty of new projects that are implementing this model in Python, which is quite interesting. But on top of that, I just wanted to make sure that if you're looking in for some really interesting talks on Python and some of the stuff you can do with it, try searching for David Beasley on YouTube. He has done several presentations both on generators and async, and all the problems you can run into with Python. That's absolutely a treasure trove of good information.
Yeah, and there's some good materials on how to do kind of parallel coding in Python. So the async IO, they say, is really kind of designed for, they call it IO bound application. So if what's limiting your application is like you're doing TCP/IP communication or something like that, you don't want to block while a file is downloading, because you could just open 2 different connections and download little chunks at a time. And a lot of Python apps are kind of web-based, so they are IO bound, but then other applications will be like CPU bound. And so there are there's like multiprocessing libraries for Python that allow you to sort of like run code on different processors as well. But you kind of have to know what's limiting your application, and then kind of choosing the right parallelism kind of framework or approach for your application.
All right, let's start wrapping up because we're running low on time here. I just want to end with everybody, if you could put out your thoughts or ideas around what's the best way, if I'm a LabVIEW programmer and I want to get started with Python, what's a good place to get started? Where are some of your resources? What's some advice on the best way to get started? I threw one of my favorite in there. There's a book called Automate the Boring Stuff with Python that's pretty good. Kind of gets you the basics of Python and gives you some ideas on what you can do. Curious if other people have good resources.
I think you have to find something practical. You have to have like a real little hobby project. I don't know. I could think of a few fun ones. So go buy a Raspberry Pi Pico or Pico W, put MicroPython on it, and download your Python script that toggles LEDs and build some cool gadget. Like, that's one thing. The other thing that's fairly accessible is try Jupyter Notebooks. If you go to Google, they have Colab, COLAB, sort of like play on collaborator. Google Colab are basically Jupyter Notebooks that are kind of like Google Docs. You can create a new notebook just like you create a new Google Doc, and that will allow you to kind of play around with just, import a module, do some math, plot your data. And you can even, import CSV files, things like that, if you want to do some data interactivity. That's kind of a cool way to learn. You can also go to I think it's called Python Anywhere. There's a website that makes it really easy to do things like set up a simple little website that has is Python powered.
Cool.
I mean, I think the comment made by Matt in the chat is pretty good, right? Just anything that you do in some other kind of scripting language, just try to translate that to Python.
Matt also makes a very good point about the additive code. I've definitely done that a few years, and that gives you some Z projects to work on where there's no pressure, just kind of play around with it. And it's also really good additive code for practicing TDD too, because they give you the test case. So it's super easy.
I would argue a couple of points. There's a Corey Schaefer on YouTube. I'll post the link in the chat afterwards. He has a huge library of all the basic stuff. Going through that is quite extensive. for getting started. If you want to build something useful, then try looking at the Anvil.works project, which actually builds web applications on Python and runs it through JavaScript in your browser. They have a great tutorial section as well. And last but not least, following what Matt pointed out, trying to automate some of your stuff. If you need to copy some files around, try learning the path library. Read the documentation in Python. It's quite good for all their tools. It usually takes about a weekend to get enough under your belt to be dangerous. So that's a really good place to start.
Cool. Any last minute questions? I think we got about 10 minutes left.
Python GUI frameworks, people just ask.
Yeah, you can spend another hour on that one.
A lot of people use Qt for anything that's kind of professional. Folks also use GTK, has good Python bindings. And then there's something new somebody just came out with, I think, which basically allows creating Flutter styled GUIs.
FLT, flat.
Flat, yeah. And it's a pretty kind of fast way to do it in Python. If it's just kind of quick play stuff, I think Flat is good, but I think it sort of runs this other application in parallel to your Python code, and it talks over TCP/IP locally. I don't know what kind of security is in it. But the that tool Nutka that I was mentioning supports Qt applications. It'll actually compile in the Qt application. You can create like really professional looking GUIs, but it does require, it's not nearly as easy as LabVIEW.
I just stumbled upon something recently called Traits UI, which seems kind of promising. I haven't really used it much, but it's maybe worth looking at.
If you're looking for something really interesting, which is not a GUI but a text user interface, you should probably look into Textual and Rich, because that's building a 60 hertz frame rendering part inside your terminal. So you can actually do GUI stuff inside your terminal, which is quite fun.
Yeah, that's the next big thing, I think.
And really useful. It's quite easy to get something running.
Yeah, I wouldn't underestimate text UIs. There are some interesting text UIs out there. Like if anybody's used LazyGet, that's a very interesting one. That's worth checking out. I don't know if that one's written in Python or what's written in, but
yeah, Google Textualize, and you'll see kind of what they're coming up with. The fellow that's doing it has become pretty popular in the Python community. I forget his name off the top of my head, but the demos, like, he's creating like calculator apps. What's that?
Will McGugan.
Yeah, I think is he a Scottish guy?
Something like that.
Yeah.
He took a year out to work on open source project, stopped his job, and then started working on open source project for a year.
Yeah.
And now he's built Textualized.
There's also some really cool stuff, and I don't know if it's related, but on creating your own REPLs and writing REPLs for your particular program and doing like autocomplete and stuff like that. And some of those are really fancy too and could be quite useful. For example, Jim, if you're generating a Python interface for something, having a REPL where you can go in and say, hey, commit, move, go,
sure,
stop, start, etc. That would be very interesting, possibly.
So being a bit cheeky, when do we get the Python interface for the package manager?
There you go. That's the good question, right? We're working on it.
Nope,
I personally would like to do a lot more Python LabVIEW interoperability. Anybody interested in some open source projects?
If I had the time, I would.
Well, the Python node in LabVIEW has apparently gotten a little bit better lately.
What's that?
The Python node in LabVIEW has gotten a little bit better. Apparently, you can use classes around now, but you can't call class methods or something.
Yeah. And that's for calling into LabVIEW or calling into
your Python from LabVIEW, yeah. Going the other way, there is an NI toolkit that does that, but apparently it says like, oh, this opens ports and allows anybody to run anything on your computer or something. I was like, so I don't know, if you look into that, there is.
That's what VI server is, right?
Yeah, pretty much.
If you know what port to look into, I guess VI server is quite
Turn
open.
on your firewall.
Yeah. Yeah, security can be important. So. All right, well, thank you guys for participating. I think we'll end a couple minutes early so people can go to whatever the next session is that they're going to go see.
But one more thing just to add is we've always had the option of building command line interfaces to Python applications. So we can always drop down into a command line to shift something to run a script or whatever needs to be done. And that's quite useful when it comes to integrating Python. You can always go through the file system that way.
That's actually very interesting because in LabVIEW, it's actually hard to create good command line applications. You can use GCLI to do that, but before that, it was very hard. So, cool. All right. Well, thank you guys very much.
Thanks for the opportunity. It was really interesting to discuss with you.
Yeah, it was a great discussion.
Yeah. Thanks, Sam. Thanks for moderating.
Thanks, Sam.
Thanks for your great input.
Good seeing you.
All right.
Bye-bye.
Good to see you guys. Talk to y'all later.
And reach out if you have questions. Definitely.
All right. Thank you.
See you all.
See y'all.
See you.